Okay, I wanted to show you all some functional upgrades that you can do to your printer build to kind of make it your own, and also add some improvements both aesthetically and functionally. Um, Obviously, I've added LED lights to mine just to make viewing my models a little easier, or a lot easier. Functionally, I added this end stop right here. I printed out a small bracket to hold the limit switch, and the very functional part is this part right here. If you can see that, this actually touches the end stop itself and activates it, and I can adjust this very finely by either turning it to the left or right. And that's what I currently use to set my Z offset. As you can see here on the extruder, I've taken off the capacitive sensor for auto bed leveling and actually changed my firmware to do away with auto bed leveling. This printer is built rigid enough that once the springs are set on the bed itself and it's leveled, that it usually stays pretty much aligned, and then I can just use the actual end stop adjustment here to make any fine adjustments, but the bed itself stays pretty level. That's one thing, and the reason I did that was I found that the capacitive sensor was extremely sensitive to heat. Not only heat from the extruder or the nozzle hot end here, because it's sat right next to it, but also heat coming from the print bed itself when using the heated bed. So what would happen is I'd get it set to level, get it calibrated nice when it's cold. Once the hot end heated up, then it would change the calibration, and it would detect at either a closer range or a farther range than what I initially set it for. So I'd reset it with the hot end being heated, and by the time the print bed itself heated up and I try to do another auto bed leveling, it would react to the heat generated from the heat bed, and its detection range would change again. So trying to insulate it proved not it wasn't I wasn't able to insulate it enough to keep it from being influenced by the ambient heat around the capacitive sensor, so I just did away with it. On my other printer here, I still have the capacitive sensor. The difference being here, it also is impacted by heat, but I have a silicone self-sealing tape underneath a piece of heat shrink, if you can see that, and then I wrap a piece of cap-on tape around it, and that does a fairly good job of insulating the heat from the hot end itself. With this other printer, I don't use ABS. I only print in PLA on this, so while I have the heat bed hardware installed, I don't have the electrical connections plugged in, so I don't use heat on this bed. I just use Elmer's purple glue, the glue stick, to adhere the PLA prints to the print bed. So I use this printer is a strictly PLA printer, and since I have it calibrated for when the hot end is preheated, I can get away with this. If I tried to do an auto home with this printer while it was cold, it would not auto home correctly, just because the detection distance would be different as opposed when it's cold as opposed to when it's hot. Okay, some other things that I did with this, on my Z-axis I printed out a knob which just allows me to make fine adjustments on the fly if need be. Like if I start my print and I find that The Z offset is not to my liking and not getting a good squish of plastic on the heat bed. I can raise or lower the bed and make a better contact, you know, or decrease or increase the distance between the nozzle and the print bed. Likewise, I also print out a knob for the y-axis that allows me to move the extruder along the y-axis. In the event that I lose steps on the y-axis, I can always pause my print, make the adjustment here, and get back in line just by going 1 or 2 clicks. And that's something that is helpful. Things that you can also do that I didn't really cover in the video are things like printing yourself out a spool holder to go on the back of the printer. That's just something I printed out real quick. It's a model that's easily made. I don't think I have this online yet because I used a recycled piece of aluminum tubing, so I don't have a set size. I didn't think it would be worth putting out there because I wasn't using a standard piece of aluminum tubing to share this model. Using a small piece of flat bar, just created a kind of a filament tender to keep the pressure from pulling on the spool from causing the nozzle to, you know, lift up in the front as it tries to, you know, feed the filament into the nozzle. As far as management of wires, you will want to manage the wires that are attached to the Z or the X-axis motor that's right here. This one gets a lot of movement, so you want something that kind of stress relief for this, so that these wires don't develop a short or break prematurely. So that's what I did. This allows most of the bending to be done by this cable housing, this wire housing, as opposed to any sharp crimping by the wire itself. I use this stuff, this corrugated tubing, in a lot of places. It also takes care of the wires that go right to the extruder and any of the electronics that I might decide to put on the head there. I run the wires here, and I tried to keep all the wires and most of the electronics out of the way underneath the printer. Here, my ramps is directly below here, and this is the USB jack that I just run an extension cord to if I need to access it. On the bottom of the printer, this underside, this is actually just the side panel from a desktop PC. You know, I repurposed it. There was the handle slot for opening up the PC cabinet, and I just printed out a cover for that just to allow my wires to feed down into it. That's right, you can find this model available online very easily. It's just a the 128 by 64 LCD display. It's just a cover for it. That I found. This other part, the part that holds the switch, I made, and it's actually a couple pieces. If you see there, I printed out this part first and then printed out the rest of the housing, and I basically just melted the plastic welded the one model onto the other so that it would fit and sit like this. I ended up insulating the bottom part of this bed. I used some fiberglass cloth that I bought from Home Depot, as well as some aluminum pipe. What's it called? I can't remember the name of the product. It's by Snow King or Frost King. It was by Frost King, and I guess it's made for wrapping pipes to insulate them. Pipe insulation. That's the best word for it. Using strips of that, I made a 1 foot square piece of insulation where I sandwiched the fiberglass insulation in the middle and taped the strips of the pipe insulation to it, and then I took that whole part and ran it through the bolts that you see here and attached it to the bottom side of the heat bed. And that just allows most of the heat that's generated to go up as opposed to leaking out through the bottom. To allow the print bed to heat up faster, I took a piece of basically a ceiling towel. It's a pretty good insulator. I put a piece of cardboard in the back, and to keep any stray fibers from going off onto the print bed, I just duct tape around the edges. And what this does is I just sit it on top of the print bed while I'm preheating, and it allows it to heat up much faster, exponentially faster, as opposed to just having it out. Because I don't have this printer does not have walls or any coverings on the sides or top, so keeping the heat in at the print bed is extremely helpful. Well, it's something that I found very helpful. Now, these are some of the prints that I have here. Like, this is the first print. It came out, if I can focus on it, it came out, I thought, pretty horrible. It was the first print, you know, proof that the printer worked. And I was printing, I think, at 0.4 millimeters or 400 micron, so it's not a very fine print. I was just testing the first one to make sure that it could print, and then the prints get progressively better. I'm almost convinced with this model that there is something wrong with the model itself, just because the prints seem to all mess up in exactly the same place. And some of the improvement was changed by my own calibration of the printer itself, making fine adjustments to the extruder here as far as the feed system, and then also with my slicer, changing up slicers and changing slicer settings also allowed some improvement. I'm currently using not slicer. I used to use slicer. I'm using Cura now, and that seems to be working pretty well. On the back side of the printer, another part of wire management that you want to make sure that you take care of. These are the wires that are for the heated bed. And you can see here, you see some of the fibers from that fiberglass I was talking about before. I keep this bolted here. I don't want these moving that much. Fortunately, the way this works, these wires will coil enough and spread the bend out over mostly the entire piece of wire here, and prevent any crimping. You know, because crimping will cause the wires to fail prematurely. And even though these are heavier gauge wires, because of the voltage that passes through them, I still want to make this last as long as possible, and that works pretty good. So you want to have wire management not just for looks, but also just for, you know, the durability of your printer. Now here, part of my wire management was printing out this small bracket. Here, this just makes sure that this stays pretty rigid and does not move around. You don't want movement here. You want your movement to be stretched out over the span of this distance, not at any one particular point. That's stress relief for your wires. So make sure you do that. And if you've gotten this far and taken care of you know, building the printer this far, these parts here will be very easy for you. So I'm confident you can take care of this part. And if you feel as though you can't, you can always ask questions, and I'll be more than happy to answer. So hopefully your 3D printer build is going good, and look forward to seeing someone post some pictures or videos of their version of this printer online sometime. I'd like to see how it turns out. Thanks for watching.